Hi, this is Jack Peters from CTC. I thought we'd spend a few minutes today talking about the proximity probe drivers. We've done quite a few upgrades to them over the past year, and it's been a very interesting and successful project. The driver itself has changed looks physically, both in the mechanics of the driver and also in the electrical connections of the driver. Looking at the mechanics of the driver, we now have a built-in DIN rail mountable clip, so we can clip that on a standard DIN rail and attach it that way. If you still like the 4-screw panel mount, we have an adapter piece that we can slip into the DIN rail area, and it snaps into place there. There we go. And now you have a 4-screw panel mount adapter. We've also added 4 terminals instead of 3. So the voltage supply and the common are 2 terminals, and the output and the common are 2 more terminals. So we've separated those commons. It just made a lot of sense too. I have separate commons there. Now on the voltage driver, don't worry, those commons are the same common. On the current drivers, those will be different. We've maintained our buffered BNC output, so if you'd like to do portable data acquisition from the driver, you can connect your data collector or analyzer right to that BNC. The other feature is we've changed the input for the proximity probe cable, and I'll connect this so we can see how that falls away better now. So instead of having that sharp 90-degree bend, we come off at a more natural angle of about 45 degrees. So we're not bending or breaking the cable as it hangs from the driver. So that's some of the physical characteristics of it, and we still maintain the 80 series driver, which is a voltage output, 200 millivolts per mil, or 7.87 volts per millimeter, and that's the common driver that you normally use in the field. In addition to that, we've added a 70 series, a 90 series, and a 91 series, which are gap, radial, and axial 4 to 20 milliamp drivers. So in those instances, you would take the 4 to 20 milliamp loop power and you'd use that to actually power the driver. And in that loop, you would return a value equal to either the DC gap, the radial vibration, or the actual movement of the shaft. We never do away with the 200 millivolts per mil. That is always there in the voltage terminals, and it's always there on the BNC. So these are just some different changes we have to make this available to process control, PLC, DCS, or SCADA systems. This has been a short presentation on the new proximity probe drivers from Pro at CTC. Remember, when reliability matters, connect to confidence with CTC. Thank you.